Hello everybody, this is our video number 7 on the same topic, the relation and function, and in this video we will also continue the exercise 1.2 from your NCERT 1.2. So consider question number 4. Show that the modulus function f from R to R, that is the real number to real number, and given by definition of fx, we already know that the modulus function definitions is neither 1 nor 1 2. Okay. So, already know that it is equal to x when the value of x is greater than equal to 0, and it is produced minus x when x greater than equal to 0, and it is produced the minus x when x less than 0. Okay, so this is the conditions of this modulus functions. So at first try to prove the 1 criteria. So let minus 1 and 1, this belongs to R, and R is a domain of this time, and if you put the minus 1 in place of x, that means mod of minus 1 is also produce the 1, and if you put x equal to 1 in place of x, and this time the mod of 1 is also 1. So from this consider f1 is equal to minus x, but 1 is not equal to minus 1. That means this f is not 1. Okay. Next, for on 2, where the minus is belongs to the R, and this time this R is nothing but a codomain. Okay. So this fx equal to mod x, please always give non negative value. That means the for this minus 1, which belongs to the R, the codomain, does not exist any x in domain R. So this time for this conditions, these f also does not hold or satisfy the 1 criteria. So F is not, not 1 criteria, it is on 2 criteria. On 2 is not on 2. So that means F is neither on 1 nor on 2. Next, next one is question number 7. 1. Okay. So in each of the following case, the state whether the function is 1, 1, on 2 or bijective. Justify your answer. For the first one, the f is a function from R to R, and define if f is defined as fx is equal to 3 minus 4x. Okay? So first try for 1, 1. For 1, 1, let x1 comma x2 is belongs to R. Okay, and this time this R is considered as a domain. So if you put the value, the f of x1 it is produced the 3 minus 4 x1, and for the f of x2 it is produced the 3 minus 4 of x2. Okay, and consider the f of x1 is equal to f of x2. That means it is implies that the 3 minus 4 x1 is equal to 3 minus 4 x2, and this from this the 4 of x1 is equal to 4 of x2, and from this we conclude that the x1 is equal to x2. That means these functions hold the 1, 1 property. After that, for the on 2, what is the mathematical conditions that is used to justify any function is on 2. This is the fx is equal to y. That means for every y which belongs to the codomain of any particular functions have some pre-image which belongs to in the domain of this function. So given fx is equal to 3 minus 4x, and this is the procedure to prove or justify any function either hold the onto conditions or not. So this time you can write this y is equal to 3 minus 4x, and from this we can easily find out the value for x, that is the 3 minus y by 4. So this is the value of x, and try to put this value in this function, and after the simplifications, after putting the value of x is equal to this in this given definition of the functions, if you get the final result is equal to y, that means this function hold this guy together, fx is equal to 1. So this time we conclude that this function also hold the onto conditions or criteria. This is the procedure to prove any function for the justifications. These functions either hold the onto criteria or not. So after that, so this x is equal to 3 minus y by 4, which belongs to R, that means the domain. So for this x is equal to 3 minus y by 4, this belongs to R, that means the domain. And this is y, which belongs to the codomain. That means if you put the value, the 3 minus y by 4 and 3 minus 4 into 3 minus y by 4, and this time this 4 is cancelled, and after the 3 minus 3 plus y, and this time this 3 is cancelled, that means this y. And after put the value of x in terms of y of the definitions of these n functions, and after putting the value of x, if it's give the final result it is equal to y, that means these particular functions also hold the onto property, and any function when satisfy both the 1 and onto criteria, then this function is also the bijective. So these functions also fulfill the bijective criteria. This is the approach to solve this type of problem. So that's all for today's lectures. Thank you everybody.